calculator to get in on it. It's just figure, and then put there. And then my third presentation. There's two versions. One of them is in the Microsoft Java thing, and one of them is without that. So take your pleasure.
Okay, what?
All right, now we're now. Where we're now. All right. So this is basically what I wanted to do was to kind of give a couple of high-level things. This is kind of a presentation of opinion. Really, this is not empirical information. So this is not necessarily something that you all should really do right now. This is more a presentation of opinion and a minor session. It's also, I believe, a presentation of a proposed or opinionated direction of where things go. And a lot of the facts or data in here are more than general trends and be literally true. So I encourage feedback from folks on some of the numbers that I've got. If they're vastly out of whack, please step up the line. I think I do a little bit better when it's interactive, but it's close to be some correctly on semantics. So at a really high level, what I want to do is kind of give a first talk about some of the historical transport systems that this thing called the internet is used. Third, talk about some protocols and technology, kind of set the stage. And then talk about service switching, which is a concept that I think is really important. And then talk about convergence and some of the likelihoods in the future. And finally, some conclusions. But I think less than conclusions are really questions that I want to kind of ask this audience that they're thinking about. So maybe 5 key points here. First off, I want to kind of set forth the notion that transport, what we traditionally call transport, it certainly isn't just the time division multiplexing signals anymore. Right? It maybe it's a little bit more than just moving happening here or there. So I want to set forth the notion that it's more about content and service delivery with quality of service and intelligence. And these are really the challenges we're going to have in transport. Secondly, we want to kind of raise some awareness on emerging trends and technologies. I don't expect everyone to agree that they're directly developed. I don't expect everyone to agree that they're real. That's not really the purpose here, just kind of bring them up. Thirdly, encourage consideration and some contemplation of some ways technology can go. So we can do better. So let's look at these as some possible ways. Fourth, get feedback from folks on the assumptions I'm making to set forth these decisions, how they're rated, and some of the perception other people have to build on a realistic proposal. And fifth, kind of the main dose here, posit the notion that NQLS and other common protocols are really useful and maybe even required for delivering quality of service and certain dynamic services. So this is kind of my version of the history of the NS. I was lucky enough to be at NSF in regional last 94, and what I know is that we had a DSA link to backup. We thought it was pretty cool. Prior to that, I think DS0 and DS1 was the amazing NSFnet. Up until about 95, 96, when folks used DS3, pretty much IP over HLC circuits, just straight circuit code. There was so much ATM. Maybe towards the end, folks like certain ISPs started using ATM and those dual circuits, DS3s. Then you started to see IP over summit start to emerge towards the end of 98 and maybe mid-97. This is kind of the first time that I think that the telephony infrastructure really kind of got married or wedded to the internet. So you started to see micro-relationship optical systems because you had to have these really weird optical OC3 interfaces on this kind of high-tech background. And nowadays, at least 3 providers, I think, announced OC192 field files or production traffic. And OC48 is kind of modern and ubiquitous. So here's 2 graphs that show the same thing. The top one is a logarithmic scale. It shows over time what the kind of my version of my view of the average backbone bandwidth or something. So back in 93, it was 56K at T1, DS3 for a while, and then OC3, OC12, OC48, 10K here. Probably think of the see a lot of ISPs doing OC1 and 2. Look at what you see on a linear channel. So, maybe this is my perception, is that in fact, the original NSF had a lot of proposals to bring back the first RFC and you read certain historical books. There was a big movement to package service routing. Maybe you could take low latency stuff and route it this way, and you could take the sensitive stuff and route it that way. I don't think that ever really proposed, but there was a lot of thought put into the original stuff. But pretty much a simple IP metrics. Then along came some folks who had big problems to solve. MCI was offered the goal to intercept that business, so they went out and built pretty big networks using it as well. And here's some reasons why I kind of remember or think that these folks used ATM. At that time, OC12 their business was supported, OC3 was supported as well. You do a lot of staff busing on it. Secondly, you could abstract fully now on the routing path, so you could take how you did top routing instead of the actual IP porting. Third, the routers were kind of driven back then. If the circuit went down, that was kind of a big deal for routers. It was not because they're still going to but if it doesn't have to be conversion later too, without having to have the routers actually think about it. It's back then, they were CPU driven, you shouldn't see CPU with more forwarding and routing phase. Fourth, you could do a better parallel circuit infrastructure. I think Odell calls this constantly parallel VS3s or something like that, or used to so you can actually have 4 ATM circuits going from one place to another and go down to over 2 circuits. I thought that was good routers. Because routers in the past had problems with load balancing. Not really problems, they didn't do so well. And so here at the third, I'd say many or that's the big advice, those favorite PLS because of the complex engineering, but it does that without the ATM 12 packs, and that's a pretty good thing. So, kind of start getting into the point I want to make is that there's more and more intelligence to the network. This is another example of a little bit with this. Another example is Cisco's WCCP, I think that's going to be road cache control protocol, which basically intercepts 480 traffic and redirects it to a cache or to a proxy. And this is a neat thing. You've got something that's traditionally just a transport forwarding element, actually making intelligent switching and routing decisions based on things other than just the destination of fields. Another example is Anaheim, San Bridges, Wyoming, and Madera, folks that are going on making service, distributing these caches and doing intelligent things at high levels. And I really traditionally thought of other big transport players, but I think as we look at how the world's evolving, we have to consider things like that. Fourth year, Anthony with distributed proxies, they don't make the item, but you get into the animal response. You have that stuff that's really kind of makes sense. So the question is, what happens when bandwidth is free? What is it going to actually be free? It will be so much cheaper than it's now with my ability. And you can kind of sense that there will be a lot of distributors to do. There will be a lot of application search traffic, which you got to understand. And so if you think of this world where bandwidth kind of is out there, what kind of problems do we as operators have to worry about? So I think traditionally, the local area network, 10 megs been around forever, something like that, about 80s. And 100 meg, it's pretty common to have 1 KB today. Pretty soon 10 gigs, higher than 18 months. In the metro area, however, I think traditionally with general further capacity, we have, for us at least, that's really been the required place to get capacity. We can barely get OC12, so we're really hard at it. Some folks will have to have our fiber, super. I think that will grow over time. On the wider area network, I think most folks would accept that, even though there's not a tremendous glut, there is plenty of capacity, at least in the U.S. And it's pretty common to get 30 deals when they do on fiber nowadays. It's not a long deal. So this is kind of the landscape that we've seen traditionally. Now I've got 2 graphs here, 2 different time points. I think we can kind of say that back in '93, 10 meg did kind of real common, but the T1s were kind of what you had on the metro and the land. So the red square there is what was kind of a limiting factor at the bottom. 96, the land started to catch up a bit. You can get PS3 start to turn that out where the land really grows by this. That's the last 2 years. But the metro is still in that area of real bottleneck. And probably in about a year or so, you'll see a lot of fiber metro deployment companies, as an example, other ones, really catching up. So you won't really have this opportunity bottleneck between the different areas. Probably ought to consider intercontinental capacity. I think that's kind of catching up with the land as well. So, some general conclusions about this, and this all kind of sets the stage and goes into the next one. Is that the metro area bandwidth demands will soon be saving. People have level 3, West, metro fiber networks. While the new fiber companies are being fiber company right now, they're building metro IP networks. If that happens, when that happens, we have quicker provisioning times. This gives us a better, higher, adequate advantage. So we no longer have to spend the collection of these 700 people's time trying to figure out how to provision stuff and trying to figure out how to figure out for it, because they're kind of trying to figure out how to do more intelligence. So in 3 year, we'll review the land manner advanced bottleneck. We have new challenges. I still think the last mile and the customer aggregation is going to take a while to catch up, but the central office, the data centers, the hearing points, and that's really there real close to now. So even though we might get this local, metro, and light area network all converged, we're kind of in the same general ballpark with each other, we still have to fix the problem that from one ISP to the next is a real, it's likely to have different service from one to the next. And this is a real barrier to quality service deployment and implementation. There's a lot of non-technical issues we have to overcome. I'm not really trying to solve that problem here. I can really point out that is a bottleneck to the quality of service in the end. But I think the demo situation for ISPs in the next probably 12 to 24 months will be kind of a real renaissance area that will have a lot of bandwidth and will provide a lot of new challenges for us. So, on to this thing I call service switching, and I'm sure people much smarter than you read papers on it, and they say it much better than I do, so we'll learn about them all for the downwards. But what I want to kind of set forth here is a framework for how a person or a network can deliver dynamic services on a converged network. So I'm not super familiar with voice over IP or telco stuff, but there's this thing in telco world called an SCP or an SCP, I think it's service transfer point, service control point. And what this is a place in the middle of the network that the telco switches can switch voice service to, and they can do things with, like do credit card authentication or do, lease cost routing, things like that. So maybe the internet would have something like that, which is not just a router or not just a cache, but kind of something in the middle, maybe it's called a classifier or something like that. It would be similar to today's proxies, but it would have a little bit more intelligence and a little bit more functionality. Well, this is what I think hierarchical MPLS or nested LSPs fit in really well, is that you can have services that become categorized and placed into certain types, and then you can switch those services to certain control points, to certain proxies or SDKs. So this is kind of a real meat of it here. If on the backbone you have a really coarse classification, so you know that, hey, this big mess of types is voice, and this big mess of types is web, and this big mess of types is VPN. Then you can manage it as a backbone operator. But you can still have high level of granularity on the edge by classifying on the edge and encapsulating the aggregate. This gives you the ability to do emission control and quality of service on the edge and manage on the backbone because it's sort of accurate as far as managing the work. So further back on MPLS, in order to make an abstract service, I would say that in order to have something in control, you have to be able to touch it, you have to be able to do something with it. So you need some concept of conduct, some concept of PVC like thing. So I believe on the backbone, the MPLS LSPs are the best delivery magnetic for this. But the end user, I don't expect, the 50,000 to come out of an MPLS segment. I think that's reasonable. I think IPsec and PVP are definitely quite adequate. So in terms of this presentation, you can basically feel more appropriate. You can change the words MPLS LSP or IPsec 911 protocol, LGP, whatever it is, pretty close to IP, but it's tangible and it's abstract and differentiates things. So this is the see if we could access that in success. What this represents like a 90-region network with metro rings, which is one of the regions for the red pops or pops that are on the transit network, and the blue pops or hubs that are on the metro network, and the green lines are like landlines between cities. So this is what your network looks like today. Maybe you want to get traffic to it. So one of the tricks that we do, and I think other people do well, is you build like a full mesh, so all your core routers talk to each other, and then you can take these granular city-to-city paths, and you can figure out the best path. And so you do that, you build a full mesh, and then maybe you have different layers of hierarchy, so you have the backbone, and in addition to the backbone, you also have metro areas that can follow up. But the trick is, you've got, let's say you've got pumps up in Seattle, Portland, and Eugene, and they're all going to New York, New Jersey, and Liberty. There's a lot of commonality between those two places in the same area. So maybe you encapsulate those in an upper layer LSP that takes those three city areas, that nine LSPs in the set, and actually bounces from the So this is kind of the concept we talk about hierarchy and aggregating LSPs. So this is pretty much the useful slide here. Let me try to explain what it means. This blue, the start blue square, it's kind of like say regional to regional LSP. This might be something from the Pacific Northwest or the New York metro area. And inside of that, you might have different service classes. The cyan, might be your whatever, your VPN type, and your magenta might be your voice over IP type. VPN and voice over IP type. And so different users could have their type routed through different paths. And this gives us as background operators the ability to say, hey, I want my VPN stuff to treat this way, or if it's out of that way, and vice versa the other way. So in a model like this, you arbitrate the middle, just like in the middle days, you decide what you want to run on a prioritized basis. And on the edge, you can admit we did. I'll talk about that here in just a second. So the benefit of a model like this is that the backbone can support it. You won't have an order and square effect. Every time an end user goes to the default, the backbone doesn't go, hey, I got to build a path. It gets put into a static pre-existing path. So there's no order and square effect. Secondly, you use service differentiation or a common translator. You can do a manual over IP. You can do call NPLS or call XSEC. You can mix these things together. You can build translators just like in the theater world. You can translate this to that without the issue. For the edge control mission, and it's kind of transport agnostic. You could have NPLS tabs being hooked up to IPsec tunnels or APCs or anything like that. So this is the same picture a couple ago, it's just a little bit added. So what we did is we added this thing of comp called services and CPU. And those are things like maybe a PSTN gateway, or maybe a cache service or image filtering service so that it can scan your video pictures. And at the edge here, you've got the cloud of the network. And the little circle there, you classify the traffic and say, well, this is web traffic. I'm going to send it to the nearest service control point, which is this white X. And it's going to intercept that traffic and send it out to the services when it is. The V in each one of the clouds represents a banding program, which I think is a pretty well-known concept. Not from like the Enron or Vandex model where you're trading data back and forth, but more from an admissions perspective. This guy sits on the edge of the LAN and decides who needs to use the 300 kilobits per second that you got voltage. The CTO, he gets what it is, this guy gets second dose, things like that. So the scaling program is a really important point because the middle of the network doesn't have to manage the arbitration, just the edge does. All the stuff in the middle of the network is static. So here's an example of how this would work. The customer has a DS3 or upstream provider, and maybe the upstream provider, either via the CPU router or the aggregation router, classifies the traffic into one of 3 different categories. First might be gold VPN traffic. What it might do is match the source and destination addresses. It might set the IP packets that push their load pointers to gold level. It might encapsulate it into an NPLS LSP that goes into the VPN, bigger LSP. And then it sets the bits on the NPLS rank so that the network knows how to arbitrate it. Second kind of traffic might be voice over IP traffic. Again, it looks at the maybe takes the same thing, something it looks at the ports, and it categorizes an LSP that goes towards the local voice over IP network. And third, it might be commodity IP traffic. Everything else just gets sent out there. No reason to play with NPLS. So some benefits is that the backbone transports so many things aggregated close. The centralized service transfer points intercept the traffic, or receive traffic that was intercepted, and it is as a do with this. You kind of put a logical overlay switching infrastructure in your network. This requires, of course, that the routers do classification, that the routers are able to classify traffic into the appropriate forwarding number. I know 10 or 2 links up there and lots of others. So then you've got distributed routing vector intelligence, and you can say, well, this kind of service goes this way, and that kind of service goes that way. Same stuff Cisco does with WCC, but apply this in the government this way. And I think some good examples of companies are folks like Shasta, Springtime, and Cosine that are making this. Traditionally, they grew up in a world where, depending upon which DSL subscriber you were, you got switched to this ISP or that ISP. Well, why not take that same model and make it to dynamic services? You can go to one company and then one identification for using. So a couple of things about conversions. And that's kind of the holy grail, I guess. I don't really have that much even to say, except that there's sure a lot of international offload, those are IP traffic using the internet. And I know my company has said that I forget, in 2002 or something like that, all of our ways to do over IP, I'm sure others have said things. The VPNs, if you think about most IP managers, when they go out and buy data connections, it's not too many of them want to put out direct T1s, I think. I observe. More want to use ATM and more want to use IP. In the metro area, fiber is really kind of a stage right now. Fiber to the home, on Palo Alto, look how that. People do fiber conduits, pretty soon the actual companies get in the game. In the wireless space, there's a whole raft of new vendors out there that do really sexy things with RF and with wireless, point-to-point, multi-point, and stuff like that. So, as far as the concept of everything over IP, companies like Cisco and Amber are building boxes that allow you to do service adaptation or whatever it is have to there, you can stick that IP and transfer it. There's also companies who do anything over ATM. And there's companies out there like Solar Desire as that are taking a solid pipe and those 12 on pipe and allowing you to split it up into 51 channels and granularly like liquid kind of move this over here and over there and then you shape it out instead of like the ATM, headers on it, and solid slices. So, as an idealist, I certainly hope that we would add everybody on IP by now, that's what we have to have. I think we are seeing more convergence and kind of doing sort of natural organizations where these things all are live with each other. So in the future, I was actually talking to someone and we were talking about how much information could a person actually use. And we had a full video, 4 screens, just a map, and that came out to 3 megabits per second. That's 1,000 times bigger than a terabit. That's pretty big. That's like 10,000 times more than we use today. But certainly, we can add in a lot more than that. Mike Odell talks about something called silicon cockroaches. The electronic devices talking together, chirping to each other all the time. An example of that, I've got a lot of people that have a T-Mode at home. I use my Yahoo as a navigation system, like our cell phone and a schedule. Not one of these electronic devices can talk to each other. So if I can just click on a button and I schedule it, we can download it, actually I have one, I guess I have. A navigation system to download the download where this, the record store is, and if you go to the recording file, you like to say, make a phone call and transfer the guy's information to his cell phone. That would sure be neat. And that's a good example of where we're going to have data transfer all around the network. So, kind of come here to conclusions or questions here. This is where I hope to get some feedback from folks. First question is how much bandwidth is enough? The demand will continue to outstretch the index supply, but I think that the supply and demand differences are not quite as large as they used to be. Intelligence network is needed in order to do the things that we all want to do. I think we need those intelligence networks at a time. But how much intelligence do we need? To what degree and how do we put the intelligence we use? I would conclude that separated services must be the ISP backbone that we need to provide those to customers, whether they're end user people, or small companies, ISPs, or large national corporations. Quality of service is really important that we have to solve this internet provider boundary management problem. And with the local area and metro area and wide area, they're fairly synchronized, the bottlenecks are going to be less acute. They're going to be more to do with it. It's going to be more end-to-end. The expectations we need to do it to be automated. So these are kind of my conclusions and questions, my view of the way that service delivery system should be done, and kind of things we need to do in the network to make it happen, and a set of assumptions that say that we can do it. And I sure appreciate any feedback and questions as to whether or not this makes sense, if people can use it, and if people can something to do. Thanks.
Nice to see you. Pardon? No, I'm not. I bet you I'm not. It's difficult with all these people needing to go to 192 to move and LT3 into traffic. But I'm not going to push that one either.
Which makes the concept of health speech from group health speech in one place to another more difficult to figure. And I think one thing we would ever consider is the management systems to build and provision these LSPs. We didn't learn the lessons from ATM, and I don't think we're still working on that kind of thing now, you know?
Yeah, I think we do that.
Sorry?
Maybe we all energy to build that around, that's why they feel like we use it.
I think we need to start considering the operator systems above and beyond like iOS and if I don't think you get jump into that and picking 4,000 LSPs is probably the right way to do it. Especially as the next LSPs and stuff.
Yeah, and hopefully the service control points can be tied to the network so that, the intelligence is tied to the database where, an element is there and not just that, only hit a button which goes out and tells the service control point and the radius and all that database is got something like this. And then the band goes on the edge of everyone. Classified, that's not that thing. Good question.
Randy Bushfield, can speakers identify themselves, please? People should look at the internet draft. It's now its third rev. It's about 2 years old, by Tony Lee, Rocco Rector, called Paste. It has two differences from this. One is it's not limited to MPLS. Secondly, it works in your provider, not just intra-provider.
Hi, Alex Bly, Concentric. I went, whatever it's called now. I went to NANOG about 3 years ago, where people stood up and said, well, one of the reasons that we don't like this ATM stuff is because you have multiple layers, you have two different layers in which routing occurs, and it's all really very complex, and things don't talk to each other. We should just get back to plain, simple, old IP and reduce complexity. And what we seem to have invented with MPLS, and I say this from a position of agnostic cynicism, is something which is far more complicated with dynamic bandwidth and people resizing LSPs dynamically than ATM ever was. I'm slightly cynical as to how this works and how this scales, apart from the increasing number of network engineers that you have to employ to maintain it.
Well, yeah, that's a good point. I mean, it certainly isn't as easy as just doing multi-point IP packets, and you've got a little bit of a connection-oriented nature and stuff, so you're right. But I think whenever you have complexity, you think philosophically in kind of two dimensions. The number of variables that you have and the complexity of each of those variables. So the simple method that we all use when you're confronted with a problem, sometimes you can divide and conquer. If you take those variables and separate them out, you might be given a whole complexity less, so you can divide and conquer. And I think with the hierarchy of the LSPs, you end up with a tangible, discrete set of things to deal with, which certainly has its own intrinsic complication. But I think that the interaction between the variables is not so much. I think it's moderately discrete, and it isn't a manageable thing. You're right, it's complicated. I mean, nothing's great. There's costs for all this stuff. But I think that this is something that would work, and I think people should.